Okay, so area between curves, we get those 8 problems. The first few are pretty straightforward. 5, 6, 7, 8 are a little more involved, so I'm going to go over number 5 right now. And hopefully clear up any confusion you might have. All right, so the first thing was find the area between the curves. The first curve, well, the first one they mentioned was y equals 1/2 x squared minus x minus 9/2. It was actually x over 2, but I changed it to 1/2. And the second curve was y equals negative 2x plus 3. So these are my sketches of these two guys. And they also said x equals 0 and x equals 5. So this gives us our boundaries that we're talking about. You see the 0 right here. So we're talking about our left-hand boundary is here. And x equals 5 is right here. Therefore, our right-hand boundary is right there. So we have to recognize two things. We have to recognize, first and foremost, which curve is the higher curve, all right, furthest north over the interval. And then we need to recognize where they intersect. So the intersecting point is going to give us our top boundary. In this case, it's going to be 0 to this x value. The y has nothing to do with it. And then the second interval is going to be this x value to 5. All right? So we need to set these two things equal. So we set our first function equal to our second function, and we're going to move it over by adding 2x and subtracting 3. And this is our new function. So 1/2 x squared plus x minus 15/2 equals 0. If we have the ability to plug this into a calculator and just find the intersecting points, that's fine. If not, we need to factor. We always would prefer to have our leading coefficient of 1. Therefore, we pull out a 1/2, which gives us 2 here and gives us negative 15 here. And if I struggle with factoring out a fraction, I can always multiply back quickly and see if I end up with what I'm supposed to end up with. So 1/2 times 2 is 1x, and 1/2 times negative 15 is negative 15/2. So we're good. Now we're talking about 0, what equals 0 here. So when we factor this, this 1/2 has nothing to do with it. When we factor, this is a very simple factor, plus 5 minus 3 equals 0. Therefore, my two zeros are x equals negative 5. That would make this 0, hence the whole thing. And x equals positive 3. Again, this would make this 0, therefore the whole thing. Because our boundary is already from 0 to 5, we do not concern ourselves with the negative 5. All right, you can see right up here, this is where they would cross at x equals negative 5, but we don't concern ourselves with that, so we can get rid of that. Therefore, this we know to be 3 comma y. We don't care what the y is. We only care about what my x value is, okay? So then we know that this is my top curve here, so negative 2x plus 3, so that's going to go first inside our integral. And our integral is from 0 to 3. Right? There's our 0 is our left-hand term, our x value is our right-hand term, or top upper bound. So this becomes negative 2x plus 3 minus the quantity, this entire blue function, 1/2 x squared minus x minus 9/2. And when we distribute that minus sign and simplify, this is what we end up with. Minus 1/2 x squared minus x plus 15/2. Notice this looks an awful lot like our original function when we solved for factoring, okay? And that's not a coincidence. That will always happen. In this case, my signs are going to be different because my upper bound is my negative 2x plus 3. And we'll figure that out. So from this point, we can integrate this two ways. We can integrate it by hand, which means we'd add 1 to that exponent and divide by that exponent, add 1 to this exponent and divide by the new exponent, so on and so forth. That's a different problem altogether. But what I'd rather you do in this case, I think the biggest part of here is determining the intersecting point and determining which function goes first. Once I get to this point, I'm going to put this in my calculator and I'm going to calculate it. It's going to come up to 13.5. So that is this orange section. So this section right here, between negative 2x plus 3 and 1/2 x squared minus x minus 9/2, is 13.5. That's how big that is. Okay? Then we move on to the second portion, which is this blue portion right there, and this becomes from 3 to 5. Okay, because we started at 3, our top function is 1 half x squared minus x minus 9 halves. Our second function, our lower function, is minus 2x plus 3. Again, we need to be careful to distribute this minus sign, and again, we're faced with a function that looks an awful lot like the two functions we've already dealt with, namely, this function right up here, and what the fuck? This function right here. The only thing that's different is the sign, the positive or negative. Alright, so once again, at this stage, I want you to plug in your calculator. You're evaluating it with a top lower bound of 3, upper bound of 5, and you get 28 thirds. Alright, you can convert it to a repeating decimal if you'd like. But remember, that's this value right here. So we just found that region to be 28 thirds. Now, you just put it on a calculator. 13.5 plus 28 thirds. Do not use the repeating decimal at this point. This is going to give you 22.8333 repeating. Math frac gives you 137 divided by 6. And that's your process. All right.